Today, we are going to work with some integration. I know that we kind of started yesterday, but we're going to work with some integration with our vector valued functions. And then you will be given a worksheet in which you will have time to begin. Okay. So go ahead and write down this example. We'll go through it together. Are you okay? What? Okay, so if this is R prime, then we know that R of t is going to be the antiderivative of R prime of t dt. Pretty linear, is that what you said? Oh, okay. I walked into physics and he had hopped on his little ball and chain and it was like spinning around just for fun. Yes. Yeah. Okay. When we take the antiderivative, what is our horizontal component? Our antiderivative. Almost. And do you see a vertical component? So we have some constant for our antiderivative. Okay. Now we know that R of 0 equals I plus J. So when we plug in 0, then our vector better equal I plus J. Okay, so what does that make C1 equal to? What about C2? So R of t is 2t plus 1 at the quantity I plus 1 J. Or more like area under X, area under Y. Like the two components separately. Well, you could think of like Y equals 2 and Y equals 0, right? Like if you're thinking about this, if Y equals 2, we're finding the area under, like if you have two separate equations and you think about the area, are you with me? So if you had like you could think of like Y equals X squared and the area under that for this component, and Y equals X and the area under that for that component. Or if you want to think about, I mean, we have a vector valued function, right? So it's the area under that curve when we actually graph it in the coordinate plane. That's not a problem. Well, no, that is a problem. No. What is the fundamental theorem of calculus? Mm-hmm. So I'll put the derivative in here, just so it's easy for us to see. Yeah. So the fundamental theorem of calculus for just like normal things is this. Whoops. Okay. So if we have a definite integral, we are taking the antiderivative at B minus the antiderivative of A. Okay, so it's still going to be the same thing for vector valued functions. We can still use the fundamental theorem of calculus. Yeah. Okay, so the integral from 0 to pi of 1 comma t dt. What is the antiderivative of 1? We don't need the plus c since we have a definite integral. T. It's 1/2 t squared, and we're going to evaluate this from 0 to pi. So we have pi, 1/2 pi squared, minus, oh, that's boring, 0, 0. It sure does. It's right there. 0, 0 is a vector. It's a 0 vector. They can make the wider the narrow. And
If it's a,
Simple what?
there's no
What
influence,
was-
it's array.
Yeah, we saw the narrow.
Yeah, array.
Yeah.
So
only a couple people did it, but.
yes, that's what a line is. Do you not remember like fourth grade? They were like, there's a line, a line segment.
No, I learned that they always, yeah, with philosophy, but that's when I, like, she's basically, doesn't use. But it looks so.
It does look so nice, and when you go back and look at it,
You're happy.